I'm Christine Stavropoulos.
Και εγώ ο Νίκος Sousamidis. Και αυτό είναι το Greek Podyssey, το podcast της ομογένειας.
A podcast for Hellenes worldwide, sharing stories, culture, identity, laughs and a little bit of tsugrisma along the way.
Γιατί μπορεί να φύγαμε από την Ελλάδα, αλλά η Ελλάδα δεν έφυγε ποτέ από μας.
This podcast brought to you by Natasha Karamiho, your trusted legal voice in Greece for all your legal matters, and Helco Consulting, trusted services for all business and investments in Greece.
Alzheimer's, your brain, children's brain. Love your brain. Today's episode is something that affects all of us in one way or another. So today's episode we have Dr Steve Kassem from UNSW, University of New South Wales and Neuroscience Research Australia. He recently was awarded the Genius Award for his work in mapping the child brain. The brain atlas of a child is the highest resolution map in the world and lets us understand the growing brain even better than ever before. I'd like to welcome, it's my great pleasure, Dr Steve Kassem. Welcome to the Greek Podyssey.
Thank you so much.
I've really been looking forward to this episode for many reasons.
Every time I have an opportunity to see you is a good time.
Thank you, Steve. I'm flattered. Your research, and let me add that Dr Kassem, and I'll call you Steve, has worked side by side with our very well-known Professor George Paxinos in the lab. Professor Paxinos is well-renowned for mapping of the brain, and he has done the most extensive work in mapping of the brain, hasn't he?
He's the best, in fact. So he's been doing brain atlasing, so maps of the brain, humans and all animals, for 60 years. He's recently been awarded any number of prizes, but one of the biggest ones was the person who has identified more parts of the brain than anyone in history. So if anyone understands the brain, how it works, how it's connected, it's him. And I'm very privileged to be able to work under him in our demountable in Randwick.
Yes.
Because in that demountable, we make, I exaggerate a bit, but we make with just the two of us and a few assistants, maps unparalleled in the world. So you've got competitive institutes in America and in Europe trying to also make brain maps, but they just don't have the accuracy or patience. And by virtue of that, he's the most cited neuroscientist from Australia and the third most in the world.
Absolutely incredible. Are there parts of the brain still not mapped? Like, how do you know when you reach the point, then you say, I have completed the mapping of the brain?
It's a fantastic question because for me, I went into it because it never stops. I'm going to give you a quick analogy. It's my favorite one. It was told to me from Professor Richard Ward. So I want you to think of the tip of a pin. How many atoms exist in the tip of a pin? We know atoms. We all know atoms. We went to school. It's about 10 million in the tip of a pin. Now and think in a grain of sand. There's 400 billion atoms in a grain of sand. How many atoms in the whole beach? Now how many atoms constitute the entire planet Earth? Still want you to keep thinking. You know how many atoms are? Okay, so it's a number you already can't think of. How many atoms for the whole solar system? And now how many atoms in the whole Milky Way? That number is smaller than the number of connections in your brain.
Unbelievable.
So the mapping never stops. The mapping never stops. We can say, look, this part of the brain is involved in this function. It does this. It gives you memory. Or it lets you move your hands. But realistically, we could map down to the single cell and it would do something different to the cell next to it. So it won't stop.
It would be like an addiction, wouldn't it? It's an addiction.
George comes to me and I share the same feeling. Every day, when can we do some work? Because we're always, you've got to do paperwork, you've got to look after students. But it's so lovely and passionately joyful to sit in front of the images of the brain and map what you see. It's quite artistic, actually.
So George has mapped the adult brain, the monkey brain, the rat brain.
Yes.
You are involved in mapping a child's brain.
That's right. As much as I like his work, I've got to make my own path too.
Yes.
So I've moved into MRI. So George would principally work post-mortem. So that's taking the brain out of a person, slicing it up, as awful as that might sound, but we put it under glass and we can see all the cells. But MRI, so the magnetic resonance imaging, you'll get one at the hospital probably, is getting to the point now where it's strong enough to get you images of the brain that are good enough to map. And so I've moved into mapping the child, and that's what I was recently awarded for. Thank you for mentioning it.
Yes.
And we've also put in a grant, which we've gotten through the first round for mapping the healthy older person brain as well. So the two other ends that are still relatively underexplored. And so in mapping the child, I have a really big interest in it. So I've come from a pretty poor background. My initial area of research was how maltreatment and poverty actually affects the brain. And so I've followed that through in various parts of my research to now, and I want to map the child brain so we can have a healthy comparison to it. So we can go, look, this is what a 6-year-old looks like, an 8, 10, 12, so on. The MRI is high enough resolution so we can map it. And it's also commonplace enough so that, if you're down, if you have to get a scan for any reason, or even just a check, you can compare it to our atlas and go, look, your hippocampus involved in memory is a bit smaller or a bit larger, or your amygdala, which makes you scared, is bigger or smaller.
That's a Greek word, by the way.
It is.
I have to say at this point, Steve is half Greek, half Lebanese. The best of both cultures and wonderful fusion of food.
The best food. Who's got better food than the Greeks and the Lebanese?
Let's go back to the child's brain. Thankfully, they're not as readily available in postmortem.
That's right. So getting a brain of an adult is still difficult, but accessible. People donate their brains. A child can't donate their organs. And so, as morbid as it sounds, it's almost impossible to get a brain of a child who's passed away. So, by virtue of that, we actually don't have any real understanding of what a child brain looks like. We understand it academically. We know, well, look, this should grow from here and this grows this way. But for a pediatrician who's doing brain surgery, he needs to extrapolate from an adult and go, well, look, an adult's brain's this size. The claustrum is here. This 8-year-old's brain looks like this, so I guess I've got to move the blade here.
There's a lot of estimation happening.
It's guesswork.
Guesswork, yeah.
We have rudimentary ideas, but there's no proper map. There's no Google Maps like you can punch in a coordinate and go, look, I need to be able to cut this part to stop epilepsy. He doesn't have a good idea. He has to sort of figure it out as he goes. And we're very grateful for everyone who can do that, but wouldn't it be better if we actually had a map there? Absolutely. And it wasn't guesswork every time? And that's one of the other big driving factors of it as well, is that we don't know. It's underexplored. We assume it looks different because it must. Children are different to us.
Absolutely.
So their brains have to be different as well.
So what sort of childhood illnesses can you identify by being able to now, well, you've mapped their brain. How does that open up to diagnostics?
And good question, because that's a lot of where the maps are used for. It's not just research, but in the clinic. And so the diagnostics come from, firstly, knowing where everything is. Like I said, so if we needed to, say, cut the corpus callosum, which is the big highway of connections in the brain, in the middle, which is a treatment for epilepsy, you have a clear idea of where that is. Now, that's a bit of a cheat answer because it's rather obvious structure. But apply that same...
Obvious to you.
Obvious to me, yeah. Perhaps it's...
Yeah, let's talk... This is a bit of an oxymoron. Brains for idiots. So they make it simple.
Make it simple.
Yes.
But there's many highways in the brain, and not all of them are in the middle all the time. Sometimes they're hidden in amongst all the other grey goo in there. And so knowing where those highways are to be able to treat epilepsy is useful. But it's not just knowing where things are, it's being able to predict where things will go. It's seeing how one part of the brain, say the insula, which is involved in schizophrenia, you can then look at that really closely with a high quality picture and compare it from the person who's being treated to a healthy control.
We're talking with children now.
With children now, even because schizophrenia develops at about 13, in adolescence is when it comes.
So you can diagnose it before symptoms manifest
Not
themselves?
just yet. So that's the third thing.
Right.
So the second thing is being able to predict it. And so you're looking at the insula and you go, look, this person's got the markers of schizophrenia. Because you can look at genetics and you can look at behavior. So you can look at that part of the brain and see if it's different already. And then the third thing is exactly what you touched on, is for other diseases, you can be able to look at it, and a doctor mightn't be able to see it from an image yet. And you mightn't be having symptoms yet. But if you go get a scan and let's say you've got a disorder that enlarges your amygdala, because we'll use that again because it's a Greek word, which can happen actually from chronic maltreatment of kids, is their amygdala grows in size. Let's say they haven't got any symptoms yet, and we get a scan, and we go, look, your amygdala is about 10% larger now than it should be at someone your age who's a boy as well, or a girl. Then something's going wrong here. Your amygdala shouldn't be 10% bigger. Let's get you to the doctor. Let's get you to the psychiatrist. Let's cut some of the time out of it and be able to go, look, you've got all the markers, although you haven't got any of the symptoms just yet, for maltreatment or chronic stress, or those are the ones that are coming to mind for that structure. go get treatment for it. Go get preventative treatment even from it before it becomes a symptomatic problem. Because you can have a larger amygdala, but unless you actually have behavioral differences, it's not that bad. Well, everyone's brain's a little different.
Yes.
But best to be aware of it and have a clear picture of what it should look like than to sort of go in there and wait for something bad to happen and then try to treat it.
Because when you get into the grips of schizophrenia, part of the problem is someone accepting that they have it and having treatment. Whereas if you get it early before the symptoms and you work it into a part of their life, that way you're preventing them from developing the full-blown symptoms. And cognitively, they're still able to understand, this is what I have potentially, this is what's going to happen to me. So let me start now, while cognitively I understand, before I'm in the grips of schizophrenia.
Absolutely. I mean, it's easier to work with someone who isn't schizophrenic yet,
Yes.
because that's obviously going to be difficult. And this applies as well to the older person brain I'm making too, in a lot more of a salient way, a more obvious way, which is dementia prevention, which is everyone's fear over a certain age, right? We don't want to lose who we are.
No.
And with the child, it's a lot of unknown territory. So it's good just to have any map there. And so I'm very happy with that. But with the older person brain, it's been looked at a fair bit. But no one's gone through and made, here is an early detector for dementia. We've got, look, if you've got early symptoms of dementia, you're starting to fail the memory test and there's the scatter plot test. All right, now's the time to go in. But by then, you've already lost a portion of your brain.
Yeah.
So just like I was saying, if we can get there before symptoms start, well, then you're not going to dement at all.
What would make someone have a scan on their brain, though, before symptoms start?
Well, look, at the moment, there's not much reason, right? They're not time-consuming and they're not that costly, but they're just inconvenient and there's a wait list, just like there is for everything. But if we can turn these types of scans I'm talking about and use these atlases I'm talking about to act as sort of like a blood test. You know, you'll go once a year to your GP, or maybe once every so many years, you'll get your iron tested and your sugar and everything, just rudimentarily done. In the same way, if we can get everyone to go get a scan once a year, once every 2 years, and just have a system look at every part of your brain and compare it to a healthy map, that's nothing then. It's 7 minutes out of your time.
There'll be people now listening to this and saying, rather not know I'm going to develop dementia, because then why would I know if I'm going to develop it and live with that anxiety? Tell us the benefits of knowing early enough.
No, absolutely. And that comes up often with a lot of things in medicine, particularly in dementia, because it's such a unstoppable force as we age, unfortunately. Everyone makes sure we're eating well, exercising well. Greek diet's the best.
We'll get to that
We'll come
part.
to that in a bit.
Yes.
But why do you want to know? Because prevention's better than treatment and prevention's better than cure. If you can know...
But is it prevention?
It is prevention. We're at the point now with treatment. We can't cure it. We can't really treat it. But if we catch you with the earliest signs now, when you're starting to just fail the memory tests and just fail the scatter tests, we can put you on a battery of pharmaceuticals. Yes, it is a battery of pills. We don't want more pills. But we can put you on a battery of pills and it will really slow it down. Really slow it down. Sometimes to the point where it will still happen, but well after you would have passed. You know, the trajectory would mean you develop it at 110. And you know what? At that point, it doesn't really matter.
Yeah.
So it's always good to know. And it's the same with anything. I'd want to know if I was going to get diabetes before I got it.
Absolutely, yeah.
But diabetes is treatable, sure. Dementia isn't. Why do I want to know? Because it is more treatable than you think. It's just that by the time you find out, it's usually too late.
Too late. And people are saying there's a higher incidence of dementia, but I don't believe there's a higher incidence. We're just living longer. So there's more time for it to develop.
I would agree entirely, except there is a bit of evidence that says there's a little bit of an actual increase. And they've measured it against diet. If we're going to go into that later, we will, but principally it's mostly because we're aging. The average age now is 80.
Everything shrinks, though, when you're aging. Except the things when you age, you grow hair where you don't want it and you lose it where you do. You shrink where you don't want to shrink and you expand where you, like the opposite happens.
Oh, that's it. That's it. And the brain will unfortunately do that. So
is there a normal parameter for shrinkage of the human brain?
There is, and it's a little bit different for everyone, but assume about 10% is the normal rule. And this isn't actually deterioration. This isn't rotting like dementia is. It's actually becoming more efficient. The brain actually hates to do work. It hates working. And we can all relate to that a little bit. And so it tries to find every possible way to become energy efficient. So, and this actually relates to the child, if you give me 30 seconds here, because with the child brain, it's actually technically got more cells in it. It's actually bigger by density than it is in an adult. And this is because it has more pathways ready to take on information, ready to store and organize itself. And then as you go through adolescence, it prunes all these pathways away and goes, look, I don't need 5 roads from this part of the brain to this part of the brain. What would be better is just one good highway. So I'm going to get rid of the 4 other roads and really solidify this one. And so the brain actually loses a bit of white matter as it goes from childhood to adulthood. And then from adulthood to, 70, 80, 90, it shrinks a bit more because it goes, you know what, I don't need 3 Westfields, in my brain metaphorically. I just want one. One's enough. And so it starts to actually utilize the brain more efficiently. It goes, this part of the brain can do more than just fear. It can do excitement. It can do mathematics. I mean, I'm being silly here just for effect, but it starts utilizing the brain more efficiently. And so it doesn't need as much space. It doesn't need as much cells. It doesn't need as much roads. And so it shrinks a little bit. So about 10% is normal.
Is there an age, at what age is the brain at its capacity, if there is any such measurement?
There's 2 points. And so there's 2 measurements that we use in neuroscience called fluid intelligence and crystallized intelligence. And they're at the 2 ends. Fluid intelligence, that's your ability to problem solve, figure out abstract problems, peaks at about 25 to 30. And that's when you're also biologically probably your fittest. And so it makes sense that the brain's its fittest and strongest at problem solving abstract problems at that age. And if you think about it, that's also where our best mathematicians usually are. Our best physicists all have their big discoveries at about 30. And then someone younger and has more fluid intelligence comes in. And so that starts to go down. But what goes up and has its peak at about 70 is crystallized intelligence. And so this is not just facts.
Experience as well?
Tacit knowledge, it's called. So things you can't necessarily teach, but are extremely good signs of intelligence. And so, yeah, they mightn't be able to figure out how to turn the Wi-Fi off on the iPad or whatever silly example we want to come up with, but they'll know how to solve this financial problem or get your career on track in ways that aren't teachable, just experiential.
That you won't grasp at the age of 25 or 30.
Exactly. And so that peaks at about 60, 70. And then, you're not that age, don't be silly. And then it doesn't sort of deteriorate until about 100. And that, you know what, at that point, I think that's fair.
Yeah.
And
considering the life expectancy years ago, before advances in medicine and science, and there's this, awful trend to be anti-medicine and anti-science now, which is counterproductive to humanity. But when life expectancy was late 50s, science has taken us to this point where you're now saying, your brain can decline at the age of 100. We never used to live that long before.
No, it was extraordinarily rare. And it's a gift if we know how to use it. Unfortunately, yes, some of us, we might get sick or we might get whatever. Don't let it slow you down. Use the time we've got. I mean, your brain is fit. Your brain is fit to 100. I mean, we were just speaking about George. I won't say his age because that would be rude, but he's still 5 days a week, sometimes 6 days a week, morning to night, working. And he enjoys it.
And he cycles to work.
And he cycles and he doesn't have sugar and all the rest of it.
Yeah, we'll talk about lifestyle a bit later on. I want to go back to the children's brain.
Yep.
And the challenges, because you've also developed MRI. The challenges of an MRI on a child was the time that it would take for a child to be in an MRI machine, which was like almost impossible. Tell us about the MRI and how you do that with a child now.
Yeah, and so this is only really possible because of the advancements we've got in MRI machines. So the research grade MRI machines, you wouldn't see at hospitals. They're at hospitals you might have seen one. They're the big clunky tubes, really noisy, and they're a bit old now, right? But you need them. And they'll be fine for many years, because you're just trying to spot big things. But on a research level, we've got 3 Tesla and 7 Tesla and more. And that's the sort of the metric you measure an MRI machine's strength of. And so a 7 Tesla machine, which is really powerful, we only have 2 in the country.
Where are they?
Ironically, not in Sydney. We've got one at Brisbane and one in Melbourne.
Right. We need one in Sydney, guys.
We do. And I traveled up to the Brisbane one with some collaborators.
Yeah.
when I was first starting this project about 4 years ago. And I'd have to go there once a month, and I'd go and do two-hour scans. So that's in the machine for 2 hours at a time. They'll let me out, toilet break, back in for another 2 hours. And I'd do that for 24 hours.
Wow.
Until I got the best possible image. Because the way an MRI image works is the longer you're in there, the better the quality, the higher the resolution. And for those that don't know, you've got to stay perfectly still. You can't move anything because the resolution of these images, the pixels, like on a TV, the pixels we're getting on the MRI are 1/4 of a millimeter big. So we're talking the size of a blood vessel.
So you're actually, are you measuring brain activity or just a brain image?
You can do both, but we just want to do brain images. We just want to get the structural image of the brain. How
So someone
it looks.
could take a Valium, for example, to relax and sleep. Does that affect the quality of the scan?
It doesn't, because that's exactly what I did. Because to stay still for 2 hours, look, we actually couldn't find participants. Originally, I was like, we'll just go get someone to do this. We couldn't offer them $100. We couldn't offer them $500. No
Offer
one
me a
wanted.
trip to Greece, I would have done.
No one wanted to be in the scanner for 24 hours. And so I did it in the end with another collaborator as well, Professor Mark Shearer. And I'm like, surely you can just knock me out or put me in a general or something. No. So I slipped a Valium and a Mercendol, and I probably shouldn't have, but it kept me perfectly still for those 2 hours. And the images we got were fantastic. But now that we got those original images, which we're making another adult map from, but that's more down the track, is I got a PhD student and myself to work on it. And we were able to get that quality of image. Now that we could achieve it, we worked backwards. And we're like, well, how can we get it for a child? How can we get it so the child can't sit still for 24 hours? Because the child's not going to sit still for 1 hour or half an hour.
No way.
And not just sit still, can't move. And that's just not possible. And just to go back for a second, that's what you were talking about. That's another reason why we don't have any maps of the child, is that we can't keep a child still for an MRI and you can't get their brains post-mortem. So we don't know how to look at it. So we worked and we sat down and I was watching ABC, as you do, and Bluey was on, if you know the show.
Yes, of course.
I'm not promoting it. I'm just saying Bluey's on. And I remember parents telling me that the only way they could get their 6-year-old to sit still was to put it on the TV. And it was 7 minutes of bliss. They could quickly run and do the chores in the house. And so, well, why not use Bluey? And we found it was like a Valium for kids.
Wow, yeah.
And so we'd put the, and obviously whatever they want to watch, you can watch things in an MRI now. And so we've been able to get, by working backwards, get the scan down to 7 minutes, which is conveniently the length of a Bluey episode or a Lego episode or whatever we want to put on. 7 minutes is more workable. Now, having done it for the past year, 7 minutes is still an ask. I mean, only today we had a 6-year-old boy in there who pressed the emergency buzzer about 6 times.
All right, yeah.
As he was getting scanned. But working through that, because that's working with kids, they can sit still. And we get these beautiful images in 7 minutes that would have taken 24 hours, which gives us that accessibility to them. And they're sitting still. You put a cartoon on or a show on, they'll sit still. And that's how we're able to do it. Now, it's not just 1 7-minute. We've got to get them to come in 4 times and have 4 7-minute goes. But I give them a $30 gift card every time, so it helps.
It helps. What does this mean for illnesses like childhood brain cancer?
Well, look, this is a big one. I'm working with, and I'm going to name drop again because I can, Professor Orazio at UNSW. He's a pioneer in children's brain cancer. And I also am on the board for the Yellow Diamond Foundation for Children's Brain Cancer, where I've been using my maps to assist where I can, because knowing exactly where a cancer is the best way to remove it without damage. Because getting a brain cancer itself is actually somewhat unavoidable. I won't talk too much about it, but brain cancer is one of the most misunderstood or poorly understood cancers. It affects
Based on why?
Well, we don't know what causes it. It affects an older person as much as it affects a child.
Mm-hmm.
There is no pollutants that we can relate to it. There's no diet we can relate to it. There's no activities we can relate to it. Brain cancer is truly spontaneous. With lung cancer, you smoke, you increase it.
Yeah.
You drink, you can get liver cancer. We know those. We've figured that out. Brain cancer, we can't get it yet. Now, there has to be some cause. But the fact that it affects a child at the same rate as it affects a 70-year-old.
So it affects a child at the same rate as wow. So how prevalent is children's brain cancer?
Look, it's the biggest killer of cancers in children. So that's at face value, that it's a big killer. It's not going to compete with, road accidents and things like that. But from a medical perspective of a medical disease, it's the biggest killer in kids. So understanding it is important. Now, my maps don't let you better understand cancer, but what it does do is let you better treat it. Because if you've got a poor map and you're guessing where you're going, and even if you get a picture, it's poor resolution and it's just a big blur, the collateral damage you can do to the brain when you try to remove that cancer is going to be worse than if you had a clear, perfect picture of the brain and you knew exactly where to go. So that's how it's helping. Well, hopefully. I'm working with the Sydney Children's Hospital. I'm an affiliate there. And we're going to start, hopefully, once we get a bit more traction and it's a bit more refined, be able to actually see it in use. And I'm working closely with clinicians and brain cancer researchers to see its use. Because, yes, I can't see how it couldn't help. And they wouldn't be collaborating with me if they didn't see the potential.
How do you go in terms of funding? You know why? Usually because we have a worldwide audience and your work is groundbreaking, and unfortunately, someone may be watching our podcast, listening to it, and thinks, wow, I either lost a child to brain cancer or, touch wood, my child has brain cancer. This is something that I need to take to the next level. Is funding a problem for you at the moment?
Look, it depends how we frame it, right? I have my job and my students will be fine for the next 2 years. But that's sort of the life of a researcher. Unless you're getting a really large grant from the government or something, other good fortune happens, you've got to spend 6 months of every 2 years fighting for grants. And we do, and I do. And we've got some success. We got a grant to do the first part of this child brain atlas. It's not the whole brain. I'm going to try and get the whole brain done with what we've got.
What's your magic number?
Look, the magic number isn't easy, but ideally, more than 2 million would be able to get this holistic done and in a position where it can be instituted at the hospital level.
Mm-hmm.
Because it's not just the manpower. It's the computer power, it's the collaborations, it's the equipment, it's the time even on the scanner, which is it's $1,000 an hour. Now, even at only 7-minute blocks, if the kid moves, you've got to restart it again. And so it gets out of hand a bit. You know, it's always awkward. You'll find every scientist finds it awkward to talk about money.
Yep. But it's a reality that we need.
It's not like we're driving Ferraris.
No, exactly.
Right?
Yeah.
We wouldn't have spent 12 years studying, to live the lifestyles that we do.
Yes.
But it's because we want to do the work we do.
It's that hunger to get to the next level, to see the outcome.
That's right. And it all intermixes as well. Funding and then research in the Child Brain Atlas then inherently uplifts the Older Person Atlas, because we'll know more about that. It uplifts brain cancer research because they'll get lifted. It's
a chain reaction, isn't it? It's a domino effect, which is important.
When legal matters affect your business or life, you need guidance you can trust. Natasha Karamihu provides expert legal advice, protecting your interests and navigating every challenge. Natasha Karamihu, your trusted legal voice in Greece.
When it comes to investments and business opportunities, you need more than promises. You need experience that delivers. You need people you can trust. Helco Consulting provides strategic partnerships, clear methods, and services with a strong presence in Greece. Helco Consulting, your trusted consultants in Greece.
Before we go into how to keep your brain healthy, I want to talk about your ethnic background and your ethnic roots a little bit, because this is the Greek Podyssey. Not that you have to be Greek, but you happen to be half Greek.
Yes.
Tell us a little bit about your background.
So it's pretty mixed. Greek from my mum. She's from Idra.
Beautiful island.
Lovely island. Dad's Lebanese from Tripoli.
Mm-hmm.
But they themselves then have bits and pieces mixed in too. Mum's got a bit of... Mum and Dad both got a bit of French in there, and there's a bit of Irish in there too. It's a very multicultural. And so as a kid, I was moving around a lot. There'd be Greek food, there'd be Lebanese food. Then you'd laugh about Greek food and Lebanese food being the same and having the same name or different. And so it was very diverse like that. And actually, I was read Greek fables as a kid in bed. So Daphne was one of my favorites, and Persephone as well. So it was definitely there, if it wasn't clear from the black hair every...
I love your hair. Don't talk about your hair.
But to speak about something a bit more personal, my mum, Jane Mustakis she was, but she changed it to Kassem when she married my dad. She was calling me one day. I was at university. I was in my 3rd year of science, and she was checking if I'm coming home for dinner, as
Greek mums do.
And I've got two siblings, one 10 years younger than me and one 15 years younger than me. Mum and dad had me very young and then decided to actually grow their family a bit later when they were a bit more stable. And so I knew her longer. And that's important to this story because I was on the phone with her and there was something that clicked in me. I knew immediately, whether it was the training, whether it was the fact I knew her so much, or it was my mum or whatever. I go, "You're having a stroke right now on the phone." And she goes, "What? No, I'm not." I go, "Yes, you are. You're having a stroke right now. I'm going to stop. I was going to go see some friends." And I said I wasn't coming out for dinner. I go, "You need to get to the hospital right now. I'm going to meet you at Westmead in 10 minutes. I'm near Parramatta. Get in the car, go now. I'm not going. If you don't go there," whatever I said, I begged her to go. She gets there before me, thankfully. Golf ball sized stroke in her brain. In Broca's area, which is the part of the brain that should prevent her from speaking. It's the only part that lets you translate your thoughts into words. She's still speaking. She's alive. The doctor says if you came here 5 minutes later, you'd be dead.
What were the signs that made you think that?
The language. So what happened was she actually had a second Broca's area on the right side of her brain. It's meant to be on the left. She has a second one on the right. 1 in 10 million people have this. She had it, so she was able to continue to speak, but she usually spoke with this poetic melody. She loved poetry and she always spoke so articulately and smoothly. But I remember on the phone, her speaking a bit jaggedly. And, Dad was watching the footy. The kids were playing games or whatever. No one would have noticed in those 10 minutes that she was having a stroke because she would have still been speaking. But thankfully, she was on the phone with me. Thankfully, I just studied what strokes were.
Unbelievable. How old were you then?
I would have been about 25, 24. Right. And I could tell straight away the way she was speaking, she was having a stroke. And so I saved her life with
You
that.
genuinely are a genius to be able to diagnose a potential stroke over the phone, talking to your mother at the age of 24. That is phenomenal.
And she still was able to speak, which is the hidden
Even
part.
more so, yes.
Because my brother and sister wouldn't have been able to tell. They wouldn't have known her for long enough. They wouldn't have heard that poetic speak in her voice all the time. It actually happened again quickly. So that made us even, I joke with her.
Yeah.
Another day, I'd finished my studies. I was going to see some friends out west and I thought I'd pop in to see Mum and Dad, get a coffee. Dad was out. Kids were out. My siblings, were out. Mum's there. She's folding clothes. She's making coffee. She goes, "Give me 5 minutes." And I'm sitting on the couch watching the TV and she collapses. No one else in the room. No one else in the house. No one expected to be back at the house. Me not to be there. I was just going past. Collapses. She has a stroke then and there. Happenstance. While I'm there for those 5 minutes, I get her in the hospital ambulance and save her life from a second stroke. Now I'm ahead, I say.
You are the model child. Imagine saving your parents' life twice. How's your mum doing now?
She's doing much better. She's obviously not perfect. 2 strokes will do that. But she's doing very well. She's in the city. She's going to the art gallery. She's getting coffee with friends, everything. So
that's it. She's doing well.
Yeah, she's doing well.
Let's talk about keeping our brain healthy. You and I have had this conversation in the past, the 5 things you need to do, and I remember you saying the number one thing you need to avoid is stress.
That's right. So like I said, I started in stress research and it's awful. There's enough evidence to actually show that stress is actually worse for you than dementia. It actually kills the brain quicker and more harshly than dementia does. So don't be stressed. That's the biggest thing you can. Try to mitigate it. If you can't remove the stress, control it. And if you can't control it, at least predict it. And that's what I got the university medal before when I finished my studies, is that prediction of stress is what can actually mitigate a lot of the damage of stress. But to cap things off, talking about dementia, keeping your brain fit.
Yes.
Stress is the big one overall. But there's been a big international study over many decades that's looked at many cultures, many ages, many people. What prevents dementia? And it's 5 things in reverse order. 1, it's the obvious one. Don't sit and do nothing. Don't just be solitary. Don't just be staring at the idiot box. Don't just be locked in a room. Be active. Be mentally active. That's a simple one. Next is exercise. 20 minutes a day is all you need, because they originally said in their study an hour a day and people complained. Then they said 40 minutes and still complained. You know what? If you have to
What's the optimal?
Optimal is probably an hour, but the bare minimum you need is 20 minutes. Vigorous walking, swimming, something like that. Break a sweat. Third, so we're getting bronze medal now.
Yeah.
Mentally challenge yourself. You have to be mentally challenging. Your brain's like a muscle. It has to be strained. It has to be challenged. You know that feeling you sometimes get when something's frustrating to learn? That's you stretching that muscle. So when you're trying to learn the iPad or you're trying to learn the phone or the laptop or whatever it is, and you hate it and you say, I can't be bothered, that's you not doing enough reps
Yes.
with your brain. Push through, learn it. Force yourself.
And it's not about doing a crossword, because if you're good at crosswords, you're not really challenging your brain, are you?
Well, you might be at the beginning, but once
Your brain learns.
you learn and you get good at it. You're
Yes.
easy at that exercise now. And so they actually talk about in the study that they give two examples. One for the academics, which is for a botanist who studies plants to then shift into biology. That's not a challenge.
No.
But to shift into mathematics is.
Mm-hmm.
Learning a new language is a challenge. Something challenging and hopefully rewarding to you. That's what it's got to be.
And that's another benefit. It's rewarding because it's personal growth.
Exactly. Wouldn't you be happier to know how to do the things in your life? Everyone would be.
Absolutely. There's so many more things I want to do in my life.
Silver medal. This is where we can all pat each other on the back. Diet. They looked at every diet. They looked at Chinese, Lebanese, Italian, Greek, American, South American, all of it. Best diet, Greek diet. Olives, not too much bread, red meat, lots of fish, lots of grains, lots of vegetables, fresh fruit, fresh vegetables, less processed foods.
Yes.
It's the Greek diet. To the point where if you eat anything, just eat the Greek diet. You're better off eating nothing sometimes and just eat the Greek diet. And then number one, most important, more than anything,
Socializing.
socializing. Not just family, not just work colleagues, but strangers as well. Because family, you don't have to, it's not much skill to socialize. Talking about the challenge before, it can be challenging to socialize with family, but you can also tell them to piss off or whatever it is you need to. So there's no social dynamics there. But with a stranger or a coffee friend or someone else a little bit further away where you have to be a bit polite, you have to think a bit.
Oh, that's all I do.
Your brain's reading the color of their cheeks, the movement of their eyebrows. It does that all automatically, and it's stretching all the little muscles in the brain. About 80% of the brain is dedicated in some way to socializing. Whether it's looking, smelling. We smell each other. We don't think about it, but we do, and that
Yes.
influences our brain too.
It triggers everything.
It does.
Because our brain is a sensory organ.
Essentially, yes, that's all it is it takes in senses and spits out cognition. And we don't know
Yes.
how it does that just yet. We know holistically that's what it does. But socialization is the biggest defense. And so dementia, the cultures that had the least rates of dementia from a lifestyle factor, genetics we can't do anything about just yet, but lifestyle is 80% of them.
Mm-hmm.
The cultures that had the least dementia were the Greeks, the Lebanese, and the Italians, because they're always socializing. Any coffee shop in Marrickville, any coffee shop down in Athens, you've got a papu there or your yaya there yelling at everyone who goes past.
Yes.
Come say hello, come have a coffee. And the same with the Lebanese and the other Mediterranean cultures. They eat the healthiest food, the least processed food, the ones best for your brain, fish, oils, things like this. And they're always challenging themselves. Granddad's in the yard learning how to grow tomatoes. You're fixing a toilet. You're figuring out how to put the gutters on. They're always active. Now, that's not to say any other cultures aren't that, but the research showed that Greeks, Lebanese, and Italians were principally the most resilient to dementia, and that's because they filled those 5 categories the best.
Before we finish the program, talk us through what is detrimental to the brain, like alcohol, for example, smoking. Like, what are the things that work against your brain and start to slowly kill it faster than what it should be dying?
So stress is the biggest one, like we said, and we said a bit about that. But so not to go over it again, avoid stress at everything. Alcohol is just poison. Like, there has been some evidence to show that socializing can outweigh the damage that drinking does. So if you need to have a glass of wine
To socialize.
you're better off doing that than not socializing, but don't go turn it into a bottle of wine.
But if you need wine every time to socialize, then that's a bit of binge drinking.
Exactly. So be mindful of it. But if you need it one day or every so often, it's not that bad. But it is poisonous. And look, I have a drink occasionally too. Smoking, obviously. Vaping, obviously. This is actually to do less with the nicotine in them and more to do with the poisons and the toxins in them that go straight through the blood-brain barrier into our brain.
Mm-hmm.
But also they damage the lungs, which then by virtue of that damages the brain through lack of oxygen transference and those obvious things. And that's the same with the heart that gets damaged from these things. But we know smoking and vaping,
recreational drugs.
and all of them, all of them
It's all
essentially.
toxins.
Caffeine has been shown repeatedly to actually be pretty good for the body.
God.
if you restrict yourself. Now, I don't. I have about 5 coffees a day, which is a lot. But 2 or less is where you should be at. And the benefits, it's not just that it's not damaging, it's beneficial because it gets the blood pumping, the heart's fitter. It's a little bit of like an aid, you know?
Yep.
But yeah, you're right. Almost all recreational drugs, some are going to be worse than others. We don't need to play a ranking game. They're all bad.
They're all bad.
But there's obviously some worse than others.
Yep.
Not being physically active. I mean, we're saying do exercise, but also don't be solitary.
Yep.
If you can't exercise, do something. Don't just sit in the chair staring at the box.
And that's what happens with a lot of the elderly when they've lost a life partner and they're on their own at home. Dementia just goes bang.
They're doing all 5 of the opposite things. They're not eating well, probably. They're not socializing. They're not exercising. They're not challenging themselves. And they're not staying mentally active.
Just to recap, before we finish off with this amazing podcast, I mean, I could talk to you for hours. We
didn't even realize how quick we were going.
No, we went really quick. There's probably people that have a lot of questions. Please drop your questions in the comments. I will take the questions to Steve and we'll come with answers if you have specific questions. Anybody that wants to assist with research funding, it's always necessary. And in the field of children's brain and brain cancer, there's a breakthrough that we can see it when you hold it up against the map of a healthy brain. You can see the differences. That is a huge breakthrough. Congratulations
Thank you.
on being given the Genius Award. You know, I can't congratulate you enough for what you do for humanity as well. Your work is vital. I love science. Science rocks.
It does.
It does. It's just fascinating what minds like yours are capable of. And you deserve every Genius Award in the world. Thank you so much, Steve.
Thank you, Christine.
And we'd love to have you back to
Please.
get updates on the research.
Answer questions, updates, anything.
Please
I'm
leave
back.
your questions in the comments. I'm sure there are plenty, particularly on, as we get older, Alzheimer's and just quick before we end, what's the difference between Alzheimer's and dementia?
Dementia is the broad term.
Yes.
Alzheimer's is the most common dementia, but you've got Parkinson's dementia, Lewy body dementia, vascular dementia. It's just the most common type.
So
and it was the first one we discovered.
We'll get you back
And we can do all of it.
Dedicate a program on
Absolutely.
that. Thank you for listening. Thank you for sharing and supporting us. Thank you to
This is
Dr.
fun.
Kassem. Thank you. We'll see you again next time.
This podcast brought to you by Natasha Karamiho, your trusted legal voice in Greece for all your legal matters, and Helco Consulting, trusted services for all business and investments in Greece.
I'm Christine Stavropoulos.
Και εγώ ο Νίκος Sousamidis. Και αυτό είναι το Greek Podyssey, το podcast της Ομογένειας.
A podcast for Hellenes worldwide, sharing stories, culture, identity, laughs, and a little bit of tsugrisma along the way.
Γιατί μπορεί να φύγαμε από την Ελλάδα, αλλά η Ελλάδα δεν έφυγε ποτέ από μας.